Students who have observed that reaching the enriching understanding stage will simply result in doing more of the same work or helping other students do their work are likely to become disengaged very quickly. So I would like us to, this is, I guess we're hitting pause with learning continuums, but to dive into something called rich tasks. And rich tasks are a fantastic way to improve your mathematics instruction and to include extension and enrichment in your classroom. If you haven't met rich tasks already, I'd like to tell you that they have a low floor and a high ceiling. This means that students at numerous learning levels can access the task, but it also means that the task can be extended for students who need to learn at a deeper level. As the task gets deeper, students have to work in a more sophisticated way and do not simply repeat the same skills. Rich tasks have extensions built in, and teachers can be aware of them ahead of time. These tasks can continue for numerous lengths of time so that students who are reaching grade level goals can still work at their own pace, while other students who are proficient early can dive deeper into their learning and thinking. If I wanted, I could do an entire multi-day professional development session on rich tasks alone. So this is purely an overview, but I'd like to point you in the direction of some resources. Here is a rich task that I use with my own students. It's called Bathtub. It's from Alicia Burtis's website, and Alicia Burtis is a mathematics educator who creates resources, and there's an entire large PDF of tasks, rich tasks that can be used for 8th grade curriculum, specifically using the Alberta curriculum, but it's very similar to the BC curriculum. In this problem, an old-fashioned bathtub has two faucets, a hot water tap and a cold water tap. The hot water tap can fill the tub in a half hour. The cold water tap has a blockage and doesn't run properly, so it takes 1 hour to fill the tub. If the two taps run concurrently, how long will it take to fill the tub? So a task like this would be used in my instruction specifically to target one of our I can statements where we are exploring the goal. So a task like this might help me answer the question, what is a unit rate? Or in what context can I find unit rates? Or maybe I can comprehend contexts where unit rates are used. Something along those lines, all building towards our final destination goal with ratios and rates. And something like this with a bathtub being filled can be accessed even by some of your students who are struggling, which is fantastic. But what is cooler is that as students solve this problem and get to know unit rates, there is an extension, and all rich tasks continue to extend. So with it comes an extension. It takes 3 minutes to fill a tub to the top and 5 minutes to drain the full tub. If the faucet and drain are both open, how long will it take to fill the tub? So students who finish the task early and can try this new extension and continue to think deeper, where other students can continue to solve the first problem. Now notice, this is not just another worksheet with two faucets that are changing. This is a deeper level of learning about ratios and rates, but we haven't left that learning. We haven't gone to a new part of the textbook. We haven't gone to Khan Academy. And it's a fantastic way to keep students engaged. I have yet, maybe on a couple of occasions, but very seldom do rich tasks hold students back. They really do push students forward. I'd like to point you in the direction of some of these, some websites for rich tasks. One of them is from Peter Liljedahl's website. And Peter Liljedahl has a book, 2021 book called Building Thinking Classrooms in Mathematics that really completely unpacks how to use rich tasks in your classroom for extension, for assessment, for everything. And his website is full of rich tasks. So I encourage you to go and check those out. The Alicia Burtis's website is fantastic, as well as some of these others. I could go in deeper, but I just want you to know that rich tasks extend on a daily basis for each one of those goals that's approaching proficiency. And it's a fantastic way to encourage and include extension and enrichment in your class. So rich tasks on the daily basis provide extension. And it's not nearly as daunting as it maybe used to be. So, and well, last thing, we don't ignore our successful students then. They continue to grow, which is great. With all of that rich task in mind, let's take a break. And when we resume, we will come back and focus on the enriching understanding portion of our learning continuums. And welcome back. I hope you had a good break. Let's note that rich tasks are a great way to increase the complexity of a learning goal for students without additional worksheets or Khan Academy or a textbook. However, rich tasks only address certain learning targets, and often those targets are the ones that you are using when exploring the goal, not the ones that you have clarified for proficiency. You'll find that some of your students are not only proficient in the targets required to approach proficiency, but they will prove that they are proficient at your for the final destination goal as well. So remember our rates and ratios and proportions example. That final destination goal was to model proportions. And what you'll note is that, and I'll talk about this later, is that we had an assessment that we were intentional about that basically addressed the final destination goal before our summative assessment so that students could see if they were confident or competent enough to dive deeper into what we would call enrichment. We've already learned that we need to consider enrichment before we dive into instruction. We've already learned that we need to expect students to be successful and reach proficiency early, and that we should be ready for them to have opportunities to enrich their thinking. We also need to know that the learning needs to be different, not the same. It just can't be extra worksheets. It needs to be new learning. And students will learn quickly that if enrichment just means more work, they will stop. Let's gather a bit more wisdom from Katie White before we realize how we can dive deeper into enrichment with our final destination learning goal. Enriching understanding involves engagement in the learning goal in ways that invite more complex thinking in increasingly varied contexts. This invites us to articulate the criteria for enriched exploration so we keep it from becoming vague or cumbersome and creating a hard edge. Sometimes this means students explore with greater complexity. For example, more difficult data, expanded vocabulary, or difficult texts. Sometimes it means they explore applicability in meaningful and deeply contextual ways, like building models, engaging the community, or designing a product. Sometimes enrichment means exploring adjacent topics that expand knowledge in the learning goal more fully. Another alternative is to have the student engage in the learning goal, but engage using a different kind of thinking, like analyzing or assessing or creating. I can hear Bloom's taxonomy in this quotation, and we will dive deeper into that today. So, when I would sum up Katie White in those quotations, the first is we must articulate enrichment. We have a path to our final destination. There is a further path that students can take, and we know what that is ahead of time. In doing so, we can either increase the content complexity or the competency complexity. We don't just flip the pages to the next textbook or the next pages of the textbook. We can augment the target so that students can continue. Here we have the learning continuum from previous, and you'll note that we have all of the information for our target and our success criteria. What is missing is the next column, enriching understanding. And underneath it says, in order to deepen my skills and understanding, then we could finish it with, I can. What could they do? What could they do to go deeper in their understanding of modeling proportions? So this could be another I can statement. It could also be phrased as a question, and I'll show you the question version in the next continuum we look at. But as students were meant to model proportions, students who reach proficiency early were tasked with a new enrichment activity, and that had to do with the golden ratio. So let's skip to the next slide. So in my exact scenario, here is how it worked. So we knew the golden ratio was in the back of our mind. My vice principal said, have you ever thought about looking at the golden ratio? And we said, that's a fantastic idea to increase content complexity, but also to break down into parts, which is analysis. Bloom's analysis is breaking something into parts, which the golden ratio forces the students to do, having just looked at regular proportions or other proportions. But in our exact scenario, I described this earlier, that the students wrote a quiz or a check-in or an entrance ticket that was essentially like it was approaching that learning goal to the closest we could get without actually doing a project about modeling proportions. Okay. And if we look at the student friendly version here on the next slide, the quiz, it had already identified real life context, but the students had to construct the model either in a diagram or something along those lines with care, accuracy, and pride. They had to demonstrate how it worked, and they had to calculate it very well. So the only thing that was missing was identifying a real life context. And students who were confident or competent on this quiz before we got to our summative assessment where we were reaching our final destination, they were encouraged to dive deeper. And they knew that on their learning map, it said, well, it says later I should try the golden ratio. And now was the chance. We had been together going up and down with our rich tasks. And then boom, we got to a point where we were just about to attempt to see if we're proficient. And what happened was some students realized early that they could do what it was that I was asking them to do with modeling proportions. Those students took a different trajectory. And at the same time, we moved the class along with one group of students investigating the golden ratio and finding a way to model it, while the other group of students creating a scale or proportional model of their choice. One group demonstrated early proficiency and showed that they could go deeper, not only just model a proportion, but see and prove the golden ratio. And everyone else stuck with what was the prescribed learning target. So this to me, I will show you other examples of using this, but this to me is the best version of this because enrichment is articulated. Students who reach proficiency early can find it accessible and they can continue to move forward. And no one is untouched. It's some of the most individualized enrichment that I've ever had go on in my classroom because it's happening simultaneously. With that in mind, you might wonder, what would I do with a test? What would I do with something like that? And we'll discuss that future. But what's important in the future, what's important is that we begin to articulate our enrichment ahead of time.